Welcome back to the classroom, everyone. Before we dive into today's lesson, please make sure to smash that like button, subscribe to the channel, and follow the account so you never miss an update. Today, we're diving into CompTIA A Plus Core 1 Objective 4.2, where we will summarize cloud computing concepts. So, what exactly is cloud computing? Simply put, it is the delivery of on demand IT resources like servers, storage, and applications over a network, which is typically the internet. To fully understand this, we're going to break it down into four main areas: the anatomy, characteristics, the location, deployment models, the architecture, service models, and the speed, storage, and delivery. Starting with characteristics, let's talk about high availability. In the industry, we strive for 5 nines uptime or 99.9999% availability. This equates to only 5 minutes and 15 seconds of downtime per entire year. This incredible uptime is achieved through the automated provisioning and deprovisioning of shared resources to ensure constant access. Next, we have to understand the difference between scalability and rapid elasticity. Scalability is about linear growth, adding nodes, which is scaling out, or adding resources to a single node, which is scaling up to meet long-term planned demand. Rapid elasticity, however, is real-time and dynamic. It's the ability to shrink and grow resources instantly to handle sudden, unexpected spikes in traffic without losing service. Another key characteristic is metered utilization, meaning you pay for exactly what you use. We track ingress, which is data entering the cloud, and egress, which is data leaving the cloud. Consumers only pay for active resource types like storage, processing, bandwidth, and active users, all tracked via reporting dashboards. When allocating these resources, they can be dedicated or shared. Dedicated resources mean the hardware is exclusively for a single customer. Shared resources mean the hardware is efficiently pooled by the provider. This introduces multi-tenancy, where multiple distinct customers or tenants securely share the same underlying data center hardware, separated logically by software. Now let's look at the location of the cloud or deployment models. This answers the questions: where does your data live and who are your neighbors? Understanding ownership and access arrangements is key. We have four primary models to understand: public, private, community, and hybrid. Think of the public cloud like an apartment complex. You have your own space, but you share public facilities like the pool and parking with strangers. These are offered over the internet by a cloud service provider and rely on multi-tenancy. The pros are that it's cost-effective, pay-as-you-go, and has no hardware maintenance. The cons are that you have less control over shared resources and strict reliance on the provider. The private cloud is like buying a house. You have complete control over your space and security, but it requires a significant investment in time and maintenance. The infrastructure is exclusively owned and managed by a single organization. It gives you ultimate control over privacy and strict access control, ideal for banking or government. However, it requires dedicated business units to manage and comes with a high cost. A community cloud is like sharing a large house with roommates who have similar needs, so you can share the rent and common areas. Here, several organizations pool their resources to share the costs of a hosted private cloud. This is ideal for distinct organizations sharing common concerns, such as specific standardization rules or regulatory security policies. The hybrid cloud is like a townhome. You own and customize your space, but you rely on shared external infrastructure when needed. It is a combination of public and private cloud elements. A great use case is keeping highly sensitive data and applications on premises in a private cloud, but utilizing the public cloud for peak traffic scaling or non-sensitive functions. Moving on to the architecture, we look at service models. What exactly are we renting? These models are differentiated by the level of complexity and pre-configuration provided. As we move from IaaS up to PaaS and finally SaaS, user control decreases while provider management increases. At the foundation is IaaS, or Infrastructure as a Service. The concept here is renting the raw IT hardware without purchasing physical machines. In this management split, the provider manages the physical hardware, while the user provisions and manages the OS, networking, and applications. Real-world examples include AWS Elastic Compute Cloud, EC2, and Microsoft Azure Virtual Machines. Moving up a level, we have PaaS, or Platform as a Service. Here, you are renting a fully configured development environment. The provider manages the hardware and the underlying OS and infrastructure. The user, typically a software developer, only manages the application code they deploy. Examples include Oracle Cloud and Google App Engine. At the top is SaaS, or Software as a Service. This is the fully finished product delivered directly to the end user over the internet. There is zero infrastructure or platform management required from the user, and it is typically delivered on a subscription or pay-as-you-go basis. Microsoft 365, Google Workspace, and Salesforce are prime examples. A specialized model you need to know is DaaS, or Desktop as a Service. This takes virtual desktop infrastructure, or VDI, and provisions it as a cloud service. It delivers a full corporate desktop environment to end users over the internet. This provides centralized data backup, simplified IT support, and allows access from low-spec thin clients anywhere in the world. Another specific daily application of SaaS is cloud file storage and synchronization, which allows files to live everywhere at once. It features automated syncing across multiple devices, real-time collaboration, and change tracking. Storage tiers are often based on replication speed and distribution. Examples include Microsoft OneDrive, Dropbox, Google Drive, or Apple iCloud. To ensure speed and delivery, we use content delivery networks, or CDNs. Think of the fast food chain analogy. If your favorite burger is only made in New York, it gets cold by the time it reaches California. Technically speaking, CDNs replicate and store files in data centers physically closer to where they will be downloaded. This drastically speeds up user access times and reduces latency. We've reached the end of our Objective 4.2 master checklist. We have covered the deployment models, service models, and core characteristics like metered utilization, elasticity, and availability. You are now ready to summarize cloud computing concepts for the Core 1 exam. To lock this in, make sure to finish your study session today by getting some hands-on practice with PBQ-like questions at XP Boost. The link is right down in the YouTube video description. Thanks for watching, and I'll see you in the next one.